What's going on, everybody? My name is Arun and welcome to my channel. In this video I'll be talking to you about Plotly. Plotly is a package that is used for making data visualizations on a web framework. Let's say you have some web pages and you want to include some graphs and charts in them, and you want them to be appealing at the same time beautiful and interactive in that manner. You can use Plotly to make that. And as a concept, and also you can also download the images from the web page and keep it on for an offline basis. Then that feature is also available. Plotly package is developed using a JavaScript library called as plotly.js, which was developed using another JavaScript library called as d3.js. Both plotly.js and d3.js is used for making interactive and beautiful visualizations for web frameworks or web pages. Alright, so after developing that, Plotly was .js was ported to other programming languages, especially Python and R, and using these you can make very beautiful and nice plots. All right. Other than these two languages, the feature is available as in JavaScript, React, Matlab, and also Julia. And there may be other programming languages wherein this port of plotly.js is available. Alright, so in this, if you go to the website plotly, alright, you just go to Plotly, and if you go to the Python plotly/python, you get a lot of fundamentals like how to make presentation APIs, dashboards, updating graphs, and making pie charts, bar charts, and all. Talking about all of this is going to be it's going to take a lot of time. So what I'm going to do, I'm just going to give you a little bit of a teaser as to how you can play around with it. If we just go to the main website over here that we were here, you can create an online account, and through which you can upload your data and then plot it on the online, and that way you have the access to the features, some of the online applications it has in the account, like the chart studio, through which you can make the data on the fly. You can also use the white label feature to have editors and make your own small analytic products. You can also have a dash so that you can make data, do some analysis of the data real time. You have an SQL client through which you can upload data or extract data from other SQL databases, and then analyze them on the fly. You also have an open source provision through which via a node package manager, node package manager, and also JavaScript file, a Plotly package, a Python package, an R package, and a dash through which you can create these files using programs. And other than that, you can also include these information after having these packages, you can make plots just like that very easily in JavaScript, Python, R, React, Dash, and a few other programming languages just like that. And it's pretty simple and straightforward and easy, and you have documentations for all of them available over here. We'll be using the offline feature so that we can recreate plots in this particular fashion over here. Okay, if you want the online version, you have to create an account, and based on how much of the features you want to access, you can get away with that with the free version, or you can get a yearly license through which after paying a certain amount of money every year, you get more features available. Alright, so this package is worth trying out because it's amazing. For most practical applications, I suppose we can get this done using the offline installations as well. I guess that should be enough. Alright, so that's enough of your 4.5 minute introduction. So let's get started. If you are using Python just like me, Anaconda Python or Miniconda Python like me, just type conda install Plotly, and that's it. It will install it directly for you. Sometimes if it did not catch up, if your Python if it cannot get this library, or if you cannot find it, we can actually you get it from the conda forge channel. So just type conda install -c and then type conda forge and then type plotly and then press enter. This way you can get your plotly installed for your Python distribution. If at all you're using pip installers, let's say, just a pip install plotly. Alright, what am I typing? Yeah, plotly, and there you go. You're good to go. Once you have this, you're good to go. Alright, now let me close up the terminal. I don't want this web page anymore. Let that be. So I will open up my PyCharm editor for PyCharm IDE for the development of the program. You can use any editor of your choice. Pick one that's convenient for you. I'm going to use PyCharm. And okay, so let's get started. I created a project, and here I have opened up an empty file called as plotly_example1. Okay, so let me push this to let me push this to presentation mode so that the font is bigger and you can clearly see without any distraction. So let's get started. Plotly example tutorial. Okay, first let's import NumPy. Of course this library does not require NumPy, but of course we need some data to plot, so let's create that using NumPy. Now let's use plotly. So if everything works out right, plotly should be you should be able to import plotly freely, without any difficulty. Just from import plotly graph_obj, we need that. You import that with an alternate name, go, and then import plotly dot offline with an alternate name, ply. Of course you're free to name it as plt. I use ply so that I don't confuse my notation with Matlab. Alright, so now with these libraries invoked, let's create some data. Create sample data. Alright, so first let's say n equals say 200 points. Okay, 201 points, and let x be some some points linearly spaced between 0 and pi. Okay, and let there be 201 points, and let y1 be the sign of x, np dot sign of x, y2 be np dot cos of x, let the data y3 be np dot y1 plus y2. Alright, so we created the sample data, and now plotly steps begin. So essentially what plotly requires is that you arrange the data in a particular format. First step is that you create traces. This is nothing but your data collections, and then afterwards create information dictionary. Essentially that will contain all your titles and stuff, and then pack the data and then plot. So this is the step. So first step, let's create some traces. This may look a bit confusing, but I'll make it as simple as possible. What you do is you just create some dictionary called as traces. Okay, so let me call the first one as trace1, and then I've used go.scatter, and then open up the braces and say x equals x, y equals y. Essentially essentially this go.scatter is actually a plotly dictionary that takes the input arguments that are required for the plot. So x stands for the x-axis for the plot and y stands for the y-axis value for the plot, and this go.scatter will give me a dictionary that I can directly plug in one single go to plot the data. Alright, now let the information dictionary be as it is, and now once we have this, we need to pack the data. So what I'm going to do is I'm going to create a list, and then I'm going to push this trace1 inside, and that's it. So what this data is that it's a list of dictionaries, and then once you have that, you just directly use the plotline feature ply dot plot, okay, and then you shove in the data, just type data, okay, and then you need a file name, and this file name has to be a HTML file. So let me say simple, what am I typing, simple plot.html, and there you go, this one's done. Is there a comma? Unresolved y? Yeah, so this should be y1 because there's no y. And now once this is done, you just run the program and give it a second, and there you go. So here, so when the program gets finished and if we don't get any errors, you will generate a HTML file, and that HTML file will be opened up in a web browser like this, and there you go. This is your beautiful sine curve. Cool. And now there's a feature over here to exploit this directly to your Plotly account if you have one. Otherwise, you can just what you can do is there's a okay. What just happened? Yeah, let me zoom out. So this is no. Okay, let this be for now. Auto scale, yeah, perfect. And now you can see this image is directly available, and you can see as and when I move my cursor, you can clearly see the x values and y values are being plotted. And over here, as you mentioned, you can pan the data, pan the figure neatly as per your convenience, and then you can zoom a particular region and see it for yourself, and then you can reset the axis if you want, toggle spike lines, and then if you just click this auto scale option, you will just get the figure in the fitting in the entire region. Cool. And now if you just click and look at the source code for this HTML, this source code will take some time, so in the meanwhile I'll show you another option. You can directly download this plot as a PNG, and that's it. Once you get you can download this. If you look at the HTML page, look at it, this is messy, and I've not even passed a few lines of code. This is the 50% code of it. The HTML data over here is massive, but you don't need any of this. You can just close this. You get this HTML, and if you right click on the image, there's this option to download this as PNG, and this is how it looks like. Come on. And this is how the PNG image looks like. So let me zoom this up. Not bad, huh? Of course, now it looks not so well printed out, displayed, should I say? But okay, this is a good start. Okay, you get a nice image over here, and it's coming out fine. And now let's spice this up and do a lot more. Add a lot more features to it. Let this HTML be as it. Okay, let this HTML file be as it is. Let me open up Python. Let me open the editor and let this be. Now what I'm going to do is add a few more features to it. Now let me write this in multiple lines so that I can keep track what it is. So that's your trace one. You can also add more features into it. Like next what I can do is I can give a name. So this name will be our label. So this is our sine curve. and then I can give a line feature to it, line, and this line has to be a dictionary, okay. This line has to be a dictionary, so let me give a color, and this color has to be a tuple, and let me give a green color, okay. And after the color we can give a line width to be say 4. Okay, you know what, I'm going to give this to be red, okay. And if this is the last entry, you don't have to give a comma, and that's it. Now if you got, this is the first trace, okay. And now what we'll do is we'll just copy all of this and paste it again, and we'll rename this. This is our trace 2, x remaining the same. This is y2, and instead of sine curve I'm going to call it cosine curve, and instead of red let me give this green color, okay. And that's it. And now let's create the third trace, so paste it again, trace number 3, and this is y3, sine plus cosine curve, and let this be blue. Alright, if there are more features that you want to put, you can actually put it over here. For instance, let's say I want this cosine curve to be dashes, have some dash, okay. So I'm going to give this option called as dash. By the way, there are other options as well. Say there is a dot and there is dash dot, okay. You know what, let this be a dot, and let me put a dash here, dash, and at the bottom over here let me have in the line dash to be a dash dot. Alright, so and likewise you can go and fill all the traces. Let me put this down. Likewise you can go and fill all the traces, okay. And now let's create a information dictionary, or there's another name for it, layout dictionary, okay. For that let me create this dictionary called as layout, okay. And this has to be a dictionary, okay. And here let's give a title. The title is some sample sinusoidal curves, okay. And now let's give an x-axis value, x-axis label, x-axis, the label is a dictionary, because it can accept multiple values, so that's why title equals what was the x-axis thing, it's angles, angle in radian, angle in radian, and then y-axis value is again it's a dictionary, so I specify title, and I specify this to be magnitude. Alright, you got this part right. And now what we can do is we see all the traces here, right? Okay, this is y3. You see all the traces here. We just have to pack all these traces into this figure. So let's put trace in this list. So that's trace 2, and then let's trace 3. Pack all the data, and then similarly, what you can do is create a figure. So let's say fig object is actually again a dictionary. Yeah, I know I totally understand if you will be like, hey, what on earth is going on? There's so many dictionaries, so many lists and all. I know, and I looked at it, this was a bit frustrating for me as well to learn, but once I got the framework, it's so beautiful, okay. It's turned out to be so beautiful. And then you put layout, it takes another argument layout, and then you put this layout argument over here, and instead of this data over here, you can remove this data, and instead of this data you can put this fig, and that's it. Alright, so that's how we go. That's how the steps are. You create all the data you want, and then you put all the create all the traces, like trace 1, trace 2, trace 3, multiple traces, and inside the traces you specify the x values, y values, name, legend name, title, and all of that. You specify all of them in separately, and then you create a layout dictionary, or the information layout dictionary, wherein you put the title, x-axis, y-axis, and all of the other information. You pack all the data to form a list. You create a figure object, and you place all the data and the layout dictionary data, and then you put this ply.plot command at the bottom, and then you finally run it. There you go. Earlier, this was the earlier plot. We can close this, and now we have the plots available here. Beautiful. So you have the sine curve in red, the cosine curve in green, and the sine and cosine curve addition in blue, and there you go. So this one is the sine curve was dashed, and this one is dotted, and this one is dash dotted, and there are a few more features to make it a little more better. Okay, and you can actually zoom in and zoom out over here, look at the data as per your wish. And here's the title, here is your x-axis, and here's your y-axis information. Now you can actually download this image as a PNG, and then if you go to your downloads folder, this will be here, and there you go. You have a nice plot available, right? And this plot has all the information you want, the title, magnitude, whatnot. It has everything you want. Sweet. That's it. And I know this is a pretty long video. This is a pretty long video. I'm just covering only one aspect of this. And now the purpose for me to make this is so that you get a little bit of inspiration, and then you can go on and work this out on your own. Alright, so hope you like this video, and this is your introduction to Plotly. And once you get the hang of all of this, this one would be pretty addictive. I have decided to use this as a good Matplotlib replacement, provided I get enough time. I felt that this is a good substitute alternative to use, so it's worth giving a try. Now that's all I have for you all in this video. Thank you for watching, and I'll see you all next time in another interesting video. Till then, take care.